Electrochemistry. Very good afternoon, everyone. So today I am going to discuss about the electrochemistry. Myself, Dr. Noorjahan Begum, working as Assistant Professor ad hoc in the Department of Chemistry, JNTUACEA, Anantapur. So I would like to discuss about the topic electrochemistry. So electrochemistry is a branch of science which deals with the transformation of electrical energy into chemical energy, vice versa. Means electrical energy into chemical energy into electrical energy. So electrochemistry serves an interface between chemistry and everyday life. When we switch on calculators, computers, radios, mobile phones, digital watch, and so on, it depends upon the electrochemical reactions occurring in the cells or batteries. A number of electrochemical industries have been established on the concept of electrochemistry, like electrorefining, electroplating, fused electrolysis, electrolytic furnace, chemical to electrical conversion. All these are depends on the electrochemistry. So next I would like to discuss about what is the meaning of electrolyte. So electrolyte is a substance that ionizes when dissolved or molten to produce an electrically conductive medium is called electrolyte. So electrolyte is classified into two types: strong electrolytes, weak electrolytes. Strong electrolytes are highly ionized in solution. Example: HCl, H2SO4, NaOH, KOH, etc. Weak electrolytes are those only weakly ionized in solution. Example: carbonic acid, acetic acid, ammonium hydroxide, etc. Next, I would like to discuss about electrical conductors. The substance which allow the passage of electric current or as electrical conductors. So these are two types: metallic or electronic conductors, electrolytic or ionic conductors. So now let us discuss what is the difference between the metallic and ionic conductors. Metallic conductors. So metallic conductors are those the conductance of these conductors is due to the flow of electron. Ionic conductors. The conductance of these conductors is due to flow of ions. So in the metallic conductors, during the conductance, there is no change in chemical composition of conductors. In ionic conductors, during the conductance, there is a change in chemical composition of a conductor. In metallic conductors, during the conductance, there is no flow of matter. In ionic conductors, during the conductance, there is a flow of matter. In metallic conductors, conductance decreases with the rise in the temperature. In case of ionic conductors, the conductance increases with increase in the temperature. In metallic conductors, no change of conductance with change in time. But in ionic conductors, change of conductance with a change in the time will be happen. Metals, alloys, certain solid salts, amides are example for metallic conductors. In case of ionic conductors, electrolytes like acids, sulfuric acid, acetic acid, bases like NaOH, KOH, and salts can be used. Next, what is the electrical conductance? So electrical conductance, it is represented by symbol capital C. It is the tendency of substance to allow electric current, or it is the reciprocal of the resistance is called conductance. It is represented by C is equals to 1 by R. The units for the electrical conductance are ohm inverse. In SI units, the units for the conductance are Siemens. The electrical conductance can be expressed in three ways. One is the specific conductance. It is the reciprocal of the specific resistance. It is K is equals to 1 by rho. So we know that rho is equals to R into A by L. If you substitute this one into the equation, K is equals to 1 by rho, finally we get K is equals to L by A C. So L by A is known as cell constant. So cell constant given cell with fixed electrolyte, it is always a constant value. And the units for the specific conductance are ohm inverse, centimeter inverse. And the SI units are Siemens meter inverse. Next, equivalent conductance. Equivalent conductance is defined as the conductance of all the ions produced by 1 gram equivalent of an electrolyte in a given solution of a volume V. That is lambda V is equals to kV, where we know that V is equals to 1000 by N. If you substitute that value in the equation, lambda V is equals to K 1000 by N. We already know that K specific conductance L by A into 1 by R. If you substitute that value in the equation, finally the equation will change to lambda V is equals to KV. So, and the units for the equivalent conductance are ohm inverse centimeters square equivalent inverse. Next, molar conductance. Molar conductance is defined as the conductance of all the ions produced by ionization of 1 mole of an electrolyte when present in 3 ml of solution. It is denoted by mu V. Mu V is equals to Kv into V. We know that Kv is equals to L by A 1 by R and V is equals to 1000 by V. If you substitute all the values in the equation, finally we get uv is equals to L by A 1 by R into 1000 by M. Units for the molar conductance are mole inverse centimeter square mole inverse. And next, effect of dilution on conductance. So the equivalent and molar conductance both will increases with the dilution and reaches to a maximum value at infinite dilution. Increasing the temperature reduces the resistance, thereby increasing the conductance. Hence, equivalent conductance and molar conductance increases with the increasing of temperature. Specific conductance decreases with increase in dilution because with increase in dilution, the number of ions present per centimeter cube of electrolyte decreases. Next, EMF, electromotive force. It is defined as the potential difference between two electrodes is known as electromotive force of cell. It is also called cell potential, EMF. It is expressed in terms of both the reduction potential and oxidation potential. Tendency to gain electron at cathode remains at a higher potential. On the other hand, tendency to lose electron at anode remains at higher potential. In terms of reduction potential, E0 cell is equals to E0 cathode minus E0 anode. In terms of oxidation potential, it is written as E0 cell is equals to E0 anode minus E0 cathode. EMF of the total cell is equal to the sum of oxidation potential and reduction potential of the right-handed electrode minus left-handed electrode. So E cell is equals to ER minus EL. Generally, electrode potential refers to the reduction potential. For example, potential of right electrode is Cu2 plus by Cu, whose value is 0.337 volts, and potential of left electrode zinc Zn by Zn2 plus, whose electrode potential value is minus 0.763 volts. If you substitute these values in the equation, E cell is equals to Er minus El, we get the value of 1.1 volts. And Nernst equation. Generally, the Nernst equation is used to calculate the electrode potential of a cell reaction. Here we take in the general equation Mn plus n electron gives rise to M. For this equation, we are writing the delta Z, that is delta Z is equals to delta Z naught plus RT ln product by reactant. We know that delta Z is equals to minus NFE. If you substitute token on these values in the equation will be comes to minus NFE is equals to minus NFE naught plus RT ln product by reactant. So finally the equation is changes to means the whole equation is divided by minus nf on both sides. The equation will becomes to E is equals to E naught minus RT by NF ln product by reactant. Then the natural logarithm can be converted into logarithms, that is E is equals to E naught minus 2.303 RT by NF log product by reactant. Here we know that R is a gas constant whose value is 8.314 joule kilo inverse mole inverse, and F is the Faraday whose value is 96,500 coulombs, and T is the temperature, that is 298 Kelvin. If you substitute all the values in the equation will be changed to E is equals to E naught minus 0.0591 by N log product by reactant. And finally, the reaction will be changed to E is equals to E naught minus 0.0591 log 1 by reactant. If you consider a galvanic cell like A plus dB, Q raised to Cc plus dB, here small d represents the number of moles of capital A, capital B, capital C, capital D respectively. The nearest equation for the equation can be written as E cell is equals to E naught cell minus 2.303 RT by NF log C to the power of C, B to the power of D by A to the power of A, B to the power of D. So the equation can also be written as E cell is equals to E naught cell minus 0.0591 by N log C to the power of C, B to the power of D by A to the power of A, B to the power of D. Here E cell is the EMF of the cell, R is a gas constant, and T is the absolute temperature, N is the number of electrons involved in the cell reaction, N is the number of Faraday's current passed, K is the equilibrium constant. If you finally come to the applications of the Nernst equation. So the Nernst equation can be used to study the effect of electrolyte concentration on the electrode potential. Determination of unknown concentration of one species in a cell is possible with the help of Nernst equation. Provide E cell and concentration of other ionic species are known. The pH of a solution can be calculated from the measurement of EMF and Nernst equation. Nernst equation can also be used for finding the valency of an ion or number of electrons involved in the electrode reaction.